Hello everyone and welcome to another webinar brought to you by the Motor Safety Association. Today our topic is going to be on safe use and handling of compressed gas cylinders. And today's topic, it's going to be kind of in relation somewhat to welding. That's typically where we're going to see compressed gas cylinders used. We'll talk about some of the different types of gas cylinders as well that you might see around some of the shops that we inspect throughout the province. But today's topic is going to mostly focus around kind of the safe use and handling of that, and we're going to kind of tie that back to some of the welding applications as well. So compressed gas cylinders, we'll see them at almost every single shop that we inspect throughout the province. They're some of the most commonly used pieces of equipment. Some businesses might engage in welding practices sparingly, while their businesses might use welding equipment and compressed gas cylinders more extensively. It just depends on their operational requirements of their business. Just kind of right out of the gate, I just want to let you know that the content in this webinar, it's intended to address smaller volumes of compressed gases, such as those seen within our membership group. And typically what we'll see is various size service shops, and for the most part, they're just going to store what they kind of use, and then obviously they'll get more as they need it. So we don't often see a lot of bulk storage, if at all. I can't remember a time when I've come across it in the 5 years I've been here. But we might have the smaller shops that'll store as little to 2 to 4 gas cylinders, and then we'll have companies that might store up to maybe a dozen, depending on the size of the shop. They might have several service bays and a few dozen workers. So depending on what their business requirements are, will usually dictate kind of what they'll store on hand or keep on hand. If you're storing larger volumes of compressed gases, that may require special or additional fire separation, special ventilation, other construction considerations that meet the requirements of the authority in your jurisdiction or area. So if you are uncertain about the applicable requirements, please contact your local authorities or reach out to the Motor Safety Association so that we can advise you on the appropriate action to take. A lot of the information today, I'm not going to necessarily reference directly to the various regulations, codes, and practices. A lot of the information in here comes out of the National Fire Code, National Fire Protection Association 55 specifically, which deals with compressed gases and cryogenic fluids. And there's various parts of the occupational health and safety regulations here in Saskatchewan that also speak to the topics that we're going to be discussing today. I'm not going to go into each and every part or necessarily cite the information right out of the regulation. Some areas I will, but just so you kind of have an overview of where the information is coming from, because you may not see it directly tied in there. And if you have any questions about that, obviously feel free to reach out to us and we can always point you in the right direction. So today, we're not going to be discussing necessarily the various types of welding processes and the wide array of practices and procedures that would accompany them. Instead, our focus is going to be more on some of the equipment involved with the welding operations, more specifically compressed gas cylinders, obviously. And we're going to speak to some of the regulatory requirements and those best practices that I just mentioned. And hopefully this will assist you in being compliant with the regulations and the requirements, but also, and most importantly, ensuring the safety and well-being of workers that work with and around this type of equipment. So our agenda for today is as follows. We're going to be discussing some of the duties and responsibilities of the various parties at your workplace, including the employer, owners, supervisors, and workers. We're going to speak a bit about how to identify the contents of a gas cylinder, some of the various gas cylinders that we'll typically see around the shops that we inspect. And often most of these shops will engage in welding operations, like I said, some more, some less. And we'll speak a little bit about the hazards that compressed gas cylinders can potentially pose at your business. We're also going to discuss safe use and handling of cylinders. This will be kind of a larger portion of the webinar today. And we'll discuss kind of general precautions to take, proper transportation for cylinders around the shop, and how to safely store them, as well as some of the safety devices that we'll see used with compressed gas cylinders. And then we'll finish by speaking a little bit about fire safety so that you're ready in the event of emergency And more specifically, we're also going to speak about kind of having a hot work plan or program to try and prevent these emergency situations from happening in the first place. If we're more adequately prepared, we will ensure, I guess, the best outcomes at our business. So starting with the duties and responsibilities. So when it comes to health and safety at your business, everybody has duties and responsibilities and a role to play to ensure that we go home safely. And taken together, we actually call this the workplace responsibility system. When it functions properly, everybody's going to have a clear understanding of their role and will be able to execute their role at a high level. So these general duties of the employer, they're actually laid out in the regulations. So this information is cited directly out of the health and safety regulations. And there's kind of two parts to this. One deals with the general duties at large of the employer at their business. And then we actually have a section in the compressed gas area of the regulations that speaks more specifically to those responsibilities, as well as it pertains to having compressed gas cylinders and liquefied gas systems at your workplace. So the general duty of the employer is to provide information, instruction, and training, and then ensure that the workers are provided with this information, and then that they're supervised competently by somebody to ensure that they're following the information. So again, we provide that information to them, we provide them with the proper instruction, and then we train them on how to execute this, and we will have somebody oversee that, typically a supervisor, shop foreman, whatever title they might go by at your workplace. It's up to the employer to also arrange for the safe use, handling, storage, and transportation of different articles and substances at your workplace. Again, kind of a general statement. This pertains to anything at your business, but for today's purpose, we are speaking more specifically about compressed gas cylinders. Employers are responsible for developing policy, practices, procedures, and rules. And obviously, policies are kind of our standards and guidelines, which we expect the workers to follow at our workplace. So it kind of lays out those general principles of this is kind of what we expect, this is how we do it. And then the safe work practices and safe work procedures to ensure that workers understand everything they need to know about the type of work that they engage with. This is the do's and don'ts of what you do with this equipment or on this job, and this is a safe work procedure. This is how we do the work safely, and then some rules, some general shop rules, hopefully, that will kind of guide them in their day-to-day activities. Employers are also responsible for reporting incidents and workers are responsible for reporting incidents. Employers are responsible for investigating those incidents as they're reported. So when we have issues come up, incidents, accidents, anything that causes injury at our business or could have caused injury, we need to investigate those things, especially when we're talking about compressed gas cylinders, as these are potentially highly hazardous and could cause a fatality if not used used appropriately. But obviously, if we're not executing that safe use, handling, and storage and transportation, we could have some big issues come up at our business. So anytime we have something related to something as serious as the topic that we're talking about today, where we have compressed gas cylinders, we certainly need to investigate that. But all incidents should be investigated ultimately. And again, general duty of the employer is to provide appropriate personal protective equipment to their workers. Now, when we speak specifically to compressed and liquefied gas systems, again, this is taken from legislation. Employers are required to develop and implement procedures for the safe installation, use, and maintenance of the systems that are used at their workplaces. So again, developing and implementing these procedures, and then most importantly, making that information readily available to the workers. The workers should be able to have access to this information. It should be, again, as it says, readily available, so that they can not only educate themselves, hopefully we've given them that education and training, but so that they have something to look back to, something to reference. Great information when we're using compressed gas cylinders is going to be your safety data sheets that come with those. And we'll speak a little bit about that here later on, but that's going to be where a great source of information comes from when we're dealing with these gas systems. And there's also other information in terms of the proper setup for these when we're attaching regulators and things like that. So we have to make sure that that information is readily available to their workers so that they have something to reference and can ensure that they are working safely. And then finally, ensure that all workers are trained and implement those safe work procedures. So not only that we've trained them to it, but now that they're executing the procedure as we expect it to be executed, as it's written, and hopefully written as a safe work procedure. A lot of companies will kind of do this. I think oftentimes what we'll see is they won't necessarily have these procedures written. They kind of take it for granted, I guess, that, we have a guy who's been in the trades for X period of time, or whatever the case is, but they kind of anticipate that that training might come from schooling or prior work experience. And we can't make that assumption. We have to make sure that our workers understand that they are trained to it. And I'd say the thing that reinforces kind of what I'm saying is that oftentimes when we inspect, we're going to see some sort of deficiency typically around either the storage of it, possibly how it's being transported, things like that. Safety equipment like flashback arresters not being on it or not being properly mounted to it. So those are things that a proper procedure and work practice are going to kind of check off. But so often, like I said, when we go and do our inspections, we see that something there is missing and that obviously somebody else is maybe not enforcing it, or these workers haven't been trained to do this properly. So, or they have, and they're simply kind of missing something in their process on day-to-day work. So supervision of work. So for supervisors, they're expected to provide adequate and competent supervision. So when we're doing work, especially when it comes to compressed gas cylinders, work that might include ignition sources and flames and sparks and all those types of things, we should probably have somebody there to competently supervise that work, or at least ensure it gets off to kind of a good start. It's typically when we have issues, it's going to come at that at the work layout. Kind of, we'll see those problems present themselves before we even start the work. Right? We have something. We've got an ignition source, and we've got something that's highly flammable, and both of them are kind of in the same workspace. So again, when we have proper supervision, and we've kind of gone through our workspace prior to the work starting and checked those boxes, we're going to be, again, more successful in terms of ensuring our safety during these types of work processes. So work supervisors also are expected to have sufficient knowledge of all matters with respect to matters within their scope. So again, they should have an understanding of the different jobs and work practices and procedures that are taking place on their shop floor, and they should competently supervise those activities, and that way we can ensure that the workers, again, I always say, bring somebody up to your level, right? We want to make sure that they are as competent as the supervisor is, so the supervisor doesn't feel like they need to be watching the whole time, although they need to provide that ongoing supervision and support. We, again, want to train people so that they don't need to be babysat, is often the word I'll hear when we're going at the shops. And that's not the intent. More importantly, the intent of competent supervision is to ensure things are set up safely, that the work is being done safely, and then we can kind of make our rounds through our shop and make sure that all the workers are doing that. We know that you can't have your eyes on them 24/7, but we need to make sure that when we're engaging in certain activities that we provide that supervision to ensure everyone's health and safety, ensure that everyone's doing the work correctly. Supervisors are expected to enforce the policies, practices, procedures, rules, and personal protective equipment usage. So again, one is responsible, the employer responsible for ensuring these things are in place. Then the supervisor's responsibility is to ensure that these things, that they understand what these things are and that they're actually happening. They're also expected to ensure safe use, handling, storage, and transportation of articles and substances, and then provide that instruction and training that we had mentioned in the earlier slide. Workers are expected to now execute, adhere to those policies, practices, procedures, and rules, utilize all the training and information that they've been provided, wear the personal protective equipment, and make sure that it's, maintained properly, and report all incidents to the supervisor, whether they're minor or major. We want to make sure that that is passed up the chain so that if something needs to be investigated or done about it, we can do so. As it pertains to compressed and liquefied gas systems, workers are required to take all reasonable steps to ensure that sparks, flames, or other sources of ignition do not come into contact with a system. So, in other words, let's have a look at our work area before we start the work, do a quick hazard assessment, and ensure that we're set up for success. Maintain the system in a clean state, free from oil, grease, or any other contaminant. We realize that shops are not necessarily the cleanest of places. However, if you have ongoing housekeeping day to day and we allow for that time to do that stuff, we're going to ensure that we have a cleaner workspace and that we run into less issues with contamination potentially. And it says secure the cap in place before transporting. So those, and we're going to see that in a picture coming up, these compressed gas cylinders have a safety cap that goes on the top. They typically will attach to around the collar of the compressed gas cylinder. They need to be in place before they're being transported. And again, that's something that's written directly into our legislation. And ultimately, they're responsible for executing or implementing the procedures. So when we look through it all, again, somebody's responsible for ensuring that the information, the instruction, the training, all that stuff is provided. Supervisors are required to take that information now and ensure that it's being executed by the workers, and the workers are responsible for the execution. So you can see that everybody kind of plays a role within this, and when we've laid that out in a structured manner, everyone's going to be on the same page and know what they're supposed to be doing. So, talking about compressed gas cylinders and the various different ways of identifying them, as well as the various different hazards associated with them. In this section, we're going to talk a little bit about that and some of the types of compressed gases that we'll commonly see at our members' businesses and some of the hazards that these pose. More specifically, we want to focus on oxygen and acetylene because it's the most commonly used gas cylinders that we will see, especially in welding practices. And they also have the highest potential for risk, I guess you could say, in terms of what, if they're not stored properly, what could potentially become an issue there. So we'll kind of speak to some of these things here momentarily, but let's start out with how we identify compressed gases. So all compressed gases, when they're received, used, or stored at your business, they must be marked by a label, tag, or some other suitable means that identify the contents contained inside of the gas cylinder according to the applicable legislation that we have. Generally, what you're going to find is that most cylinders will have a label on the shoulder of the cylinder, as you can see in this picture, which will identify the contents of the cylinder, the distributor of the product. It'll briefly outline some of the hazards of the gas. So those labels are extremely important, and they serve as the workplace label for the cylinder. They should never be removed or marked up or written on. Leave them as is. Any cylinder that cannot be positively identified must not be used. We understand that throughout the course of work, as these age, possibly they're outside, maybe they get a bit of sun, we understand that they might deteriorate over time. So if that happens, again, don't use it. Mark it as contents unknown if you don't know the contents in that cylinder, and return it to the compressed gas supplier. If you know what's in it and the label becomes illegible or accidentally removed, ensure that the labels are replaced. Reach out to the supplier, get a supplier label, or create a workplace label in the same vein as the supplier's label. When we're looking at compressed gas cylinders, never rely on the color of the cylinder to identify the product inside of it. The color coding system of gas cylinders, it's not standardized and it shouldn't be used to verify the contents inside of the cylinder. That might come full circle one day, but as it stands right now, again, this isn't a standardized practice in terms of the colors of the cylinders, so don't use that as the principal means of identifying it. The primary means of identification of its contents is the workplace label that we just mentioned, which is why we return it to the supplier if we can't properly identify what's in it. Manufacturers and suppliers must supply safety data sheets for the cylinders you're purchasing. And all workers who are going to handle and use compressed gas cylinders at your business, they need to be educated on those safety data sheets. How to read properly. So again, we go to training and then site-specific training. We'll kind of discuss that momentarily. voluntarily. But they need to understand how to read these safety data sheets. At MSA, we often mention and encourage businesses to develop those site-specific witness training programs. So these programs are meant to educate and train your staff on the chemicals and products that they use at the workplace during their course of their employment. And that's actually a requirement by Saskatchewan health and safety legislation. So we're not just giving them that generic witness training, we're giving them site-specific information about the different chemicals, gas cylinders, and things that they're going to use at the business, and making sure that they're trained to each so that they understand the potential hazards and how to protect themselves. And at the Motor Safety Association, we've actually developed a training template that can be used as a guideline for you to train your staff for the products used at your business, and I'll include that actually as an attachment and send it out as an email for anybody who attended live today. Another important and often overlooked item is having signage for areas where compressed gases are stored. So that signage might say danger, compressed gas cylinder storage, or maybe even go as far to indicate the type of cylinders stored in the area, whether they're flammable, oxidizing, corrosive. Use signage wherever you can or whenever you can. Again, it's one of those things that kind of denotes what the hazards are in that area, and it's always a good practice to use those as they will alert people to the potential hazard in the area. Here's a little picture for you guys. I'm not going to go through every single thing here. I mean, most of you are probably familiar with this, the various components here of a compressed gas cylinder. But as you can see there on the bottom left, the cylinder, the shoulder has the label on it. Sometimes you'll find those on the body, but generally we're going to find them right on the shoulder of the gas cylinder. But not to say that you couldn't find it somewhere else, or it could be affixed to the body of the cylinder as well. You can see the other various components, our pressure relief valve there, the hand turn wheel valve connection, where we're going to put our regulators typically, and the threaded cylinder collar there where the safety cap would twist on. So this would kind of give you an idea of what it looks like with that the regulator setup. So we see that attachment there and all the other components here that we had just mentioned prior to this. So looking at the various hazards of compressed gas cylinders, so there's a number of hazards associated with handling, using, and storing compressed gases. We have pressure hazards, right? High pressure. All compressed gases are hazardous due to the high pressure inside of the cylinders. So damage to that cylinder valve can result in a rapid release of the high pressure, and that can ultimately propel the cylinder, making it almost like I don't want to say a missile, but a projectile essentially because of the pressure contained in it. So that's why we say when you're transporting these things, make sure that that safety cap's on, because if that tips and that top piece gets sheared off, this thing's going to become like a rocket. So we want to ensure that when we're transporting the gas cylinders, when they're not in use, that we have those safety caps on. Excuse me. All compressed gases are hazardous due to that high pressure inside of the cylinder. So internal cylinder pressures, they might go as high as 6,000 pounds per square inch PSI, but are typically between that 2,000 to 3,000 PSI range. And to better understand how high the pressure of compressed gases actually is, think about a car tire. The pressure is usually between 35 to 45 PSI in a tire. And if you've ever seen a tire zipper and the type of explosion that comes from a tire that zippers or ruptures, it's quite aggressive. So you can only imagine the type of pressure coming out of a compressed gas cylinder. So again, damage to that cylinder valve can result in that rapid release of that high pressure, and we want to avoid that at all costs. We've got fire and explosion hazards, so flammables such as what we talked about, acetylene, that's what we're going to focus on. Butane, hydrogen, they can burn or explode under certain conditions. So if flammable gases are allowed to accumulate under certain concentrations, or it's between their defined lower exposure limit and that upper exposure limit, an explosion could potentially occur if there's an ignition source present. So we want to avoid those situations. And obviously, if we've got contamination, we've got sparks, and we've got different ignition sources present, this could be very hazardous, especially when we're dealing with some of those more flammable or explosive type gas cylinders, such as acetylene potentially, and propane, things like that. Health hazards. So many gases are toxic. They can cause serious health problems depending on the gas, its concentration, length of exposure, route of entry, all of those things. And health symptoms of exposure to gases can be immediate or delayed. So proper ventilation should always be at the top of mind when we're working with any type of toxic gases, especially. So having a fume hood, ventilated gas cabinet, working outside, storing them outside, things like that. Sometimes permanent gas detectors might be required, or need to carry personal gas detectors for leak detection. It's going to depend on the circumstances. Gas detectors and monitors, they have to be calibrated and maintained as per the manufacturer's operating instructions. So we have to keep that in mind. And again, that's going to come down to what's being stored, also volume, where it's being stored, things like that. So anytime we've got those situations, we have to ensure that records of the maintenance of those gas detectors is maintained on an ongoing basis. Got chemical burns potentially, so some compressed gases are going to be corrosive. They can burn or damage the skin on contact, burn the eyes, lungs if inhaled, as well as attack and corrode metals even. So we want to ensure that we've got the proper personal protective equipment available to us. And again, proper ventilation and exhaust systems as well. And anyone required to wear respiratory protection also must be trained and fit tested before starting to use their respirators. So anytime that we need to use respirators for these different types of gases or chemicals, again, workers need to have that tight fit. They need to be fit tested, and we need to be able to show proof of that testing. Got potential asphyxiation hazards. So asphyxiation is the main hazard when we're talking about inert gases such as helium, argon, nitrogen. If those gases escape undetected in the atmosphere, they can quickly reduce the oxygen levels in that area below concentration that's necessary to support life, essentially. So again, there are asphyxiants. We have to be aware of those. And physical hazards. So compressed gas cylinders, they're large, they're heavy, they're awkward to handle sometimes. So ensure that we've got proper lifting practices, because improper handling or not properly securing cylinders while in use can cause cylinders to fall or cause injury to workers. So we need to understand that safe lifting practices and how we transport these items are going to be essential to ensuring that we don't have any sort of ergonomic related injuries, lifting injuries, things like that. So these are some of the compressed gases that we might see at the various businesses. I'm going to focus kind of on the last two, oxygen and acetylene, but we'll kind of go through some of the other ones we have on this list. So we've got nitrogen, argon, helium. They kind of all fall within the same realm. These gases can cause rapid asphyxiation and death if released in a confined area. They are odorless. Their main characteristics are they're odorless, no warning signs before unconsciousness occurs, so it could be instantaneous. At high concentrations, they can potentially cause death if you become unconscious. They do not burn, and they're considered inert gases. So oxygen deficiency monitors should be used whenever large amounts of these gases are present in a specific work area, but typically we're not going to see large amounts of these in the shops that we inspect. Carbon dioxide, it's primarily an asphyxiant as well, but also has mild toxic properties. So some of its main characteristics can cause the nose to sting, much heavier than air. It'll collect in ducts, drains, low-lying areas, potentially cause unconsciousness. Instant unconsciousness may occur, and again, death potentially if there's high concentrations. So for these reasons, a carbon dioxide monitor should be used when there's a risk of CO2 exposure, rather than an oxygen deficiency monitor. We've got hydrogen. Hydrogen's a flammable gas. A mixture of hydrogen and oxygen or air will explode potentially in a confined area in the presence of a spark. So a hydrogen flame is, by the way, virtually invisible in a well-lighted area. So again, something to be cautious of. Again, not a ton of hydrogen that we see used, but some of the main characteristics of it, it's odorless, much lighter than air. Again, it'll collect at the highest point in any enclosed space, unless there's a high level of ventilation. There's a fire and explosion hazard, obviously, there. and very low ignition energies. Those are some of the main characteristics for hydrogen. Now, kind of the two that we'll focus on a little more too is oxygen and other oxidizing gases. So oxidizing gases such as oxygen, they're non-flammable, but in the presence of an ignition source and fuel, they can support and vigorously accelerate combustion. So we need to be very aware of how these items are stored when they're not being used. So oxygen, acetylene, they work great together when we're welding, but when we store them, we need to store them separately, because if one of them for whatever reason has a leak or something happens, possibly I was going to say, the top gets sheared off, but we shouldn't have that issue if we've got those safety caps on. But the idea is if one becomes potentially exposed, or we've got an issue with one, if they're stored together, we've kind of created a bit of a bomb situation, right? So we want to store those apart so that if we have a leak or something like that, we don't run into the issue of a potential larger situation or an explosion because of that. So oxygen enrichment of the air, even by like a few percentages, it considerably increases the intensity of fire. So sparks, which would normally be regarded as harmless, can cause fire in materials which do not normally burn in air, such as fireproofing materials, to actually burn quite vigorously in oxygen-enriched air. So again, they're an accelerant, right? They're going to add fuel to the fire. Some examples of those commonly used oxidizing gases, we mentioned oxygen, also nitrous oxide, chlorine, fluorine. Those would also be oxidizing gases. So cylinders that contain oxidizers, whether full or empty, they got to be stored away from fuel gas cylinders at a minimum of 20 feet. And we're going to get into some of the more specific stuff here momentarily about storage, transportation, and things like that. The main characteristics for oxidizers are odorless, generally considered non-toxic at climatic pressure. We do have to be considerate though if it's going to be in really high heat outside or even really cold temperatures outside as well. Typically oxidizers will not burn but support and accelerate combustion, right? So that's the main thing, is that they are an accelerant for flammables. They're materials that are not normally considered combustible but may be ignited by sparks in oxygen-rich atmospheres. No oil, grease, or lubricant should come into contact with oxygen. So when we're looking at acetylene, again, that's kind of the one that works well with oxygen. We have to keep in mind acetylene is an extremely flammable gas. It's different from other flammable gases because it is generally unstable. Under certain conditions, it can actually decompose explosively into its individual elements, which is carbon and hydrogen. Some of the main characteristics of acetylene is that it has a distinctive garlic smell, even at very small concentrations. If fire and explosion hazards are greater than, excuse me, than liquefied propane, but it's slightly lighter than air and less likely to collect in ducts and drains. And it requires minimal energy to ignite in air or oxygen. So again, we need to be really cognizant of that. Under certain conditions, acetylene forms explosive compounds actually with copper, silver, and mercury. So we don't want to use copper fittings or tubing on acetylene tanks. Contact between acetylene and these metals and their salts, it needs to be avoided. Acetylene will also react violently with things like fluorine and other halogens. Stainless steel and carbon steel are the best choice typically of material to use for fittings, gauges, and piping when we're using acetylene gas cylinders. So let's get into safe handling and use. So when we're looking at safe handling, use, transportation, things like that, cylinders that contain oxidizers, whether they're full or empty, they must be stored away from fuel gas cylinders like propane, acetylene, hydrogen. They need to be stored at a minimum of 20 feet away. In the event they're stored together, they must be separated by a wall that is 5 feet high with a fire resistance barrier of at least 30 minutes. If the cylinders are stored indoors, the area must be fully equipped with sprinklers, okay? So, because we will often see these stored inside in parts rooms or in various areas of shops, but we have to make sure that we've got fully equipped sprinklers if that's the case, because if something happens, we have that explosion, God forbid, we need obviously something that is going to be effective at fighting that fire. Oxygen is an oxidizer gas, and it strongly supports and accelerates a flame or fire. And again, that's why we store oxygen and acetylene away from each other, or we have that fire barrier in place. Obviously, the more distance we can get between the two things, the better. 20 feet, it's a minimum of 20 feet. You can always store them further away, especially if we have any sort of concerns there. Large quantities, as we said before, they might require additional provisions be met. So it's recommended to store as little as possible, and that's generally what we'll see when we inspect. Additionally, local bylaws may differ from township to township, city to city, so it's highly recommended you consult with your local fire marshal or fire detachment to ensure that you meet the local requirements for compressed gas cylinder storage. They'll often do walkarounds with or for you folks, so if you have any concerns there, reach out to them and see if they can do a walk around. And if you have questions, you can certainly ask them or bring them to us, and we'll do our best to address them. Safety data sheets, they'll act as a great reference tool to know what gases are compatible and incompatible with one another. Always refer to your safety data sheet if you're unsure. Provided actually a safety data sheet for oxygen and acetylene as an example, and I'll try and attach them to the webinar here today so that you can have a look at those. But easily found online, these safety data sheets for these items. So it's just a quick reference table on how gases should be separated according to TDG. So again, when we're talking about compressed gas cylinders, we're going to get into some TDG, transportation dangerous goods and women's related materials. And this actually comes from TDG, and it gives us a little bit of an idea on what the general segregation requirements are. So just to kind of give you a higher level a quick debrief on this. Flammable gases need to be stored away from oxidizer gases. Inert gases can be stored with flammable or oxidizer gases. And propane must be located at least 1 meter or 3 feet away from flammable compressed gas, and at least 6 meters or 20 feet away from containers of flammable, combustible, oxidizing, corrosive, or toxic liquids. Okay, so oftentimes we'll see kind of propane just tossed in with the rest of it. That shouldn't be the case. It needs to be stored separately. So when using gas cylinders, there's going to be a number of general safety measures that we should adhere to. Individuals working with gas cylinders need to be appropriately trained. So we talked about TDG, WHMIS, site-specific WHMIS. Make sure that our employees have that training and that they understand it. And obviously, a supervisor should be checking in and making sure that they're adhering to that sort of the training that they've received in regards to those items. Gas cylinders are only to be used for their intended purpose. So, oxygen isn't air. You shouldn't be using it to spray off your coveralls, things like that. So they should only be used for their intended purpose, and that's obviously essential to health and safety. We have to ensure the equipment is compatible with the cylinder pressure and content. So regulators and things like that, they can be verified actually using the Compressed Gas Association website, so you can see or ensure that the proper fittings, regulators, things like that are being used for whatever gas cylinders that you're storing at your business. Wear personal protective equipment. Wear appropriate personal protective equipment for the hazard potential of the material that you're working with and the compressed gas that you're using. Refer again to the safety data sheet for details on the safe handling of that compressed gas cylinder. And at a minimum, you should be wearing long sleeves, safety glasses, gloves, long pants, closed toe, closed heel shoes, things like that. So again, refer to the safety data sheet. It'll often give you some good information on that. Remove any dirt, grit, or oil, rust from the valve and fixture. Keep them clean, right? These can cause gas leaks potentially if they get into a valve or a connection. So keep those clean. I think that's because they stand up and they're upright. Generally, we don't see a lot of that happening, a lot of that grit and dirt on compressed gas cylinders. But if you do see it collecting, address it right away so we don't run into these issues. Ensure that proper regulator fittings are used for the particular gas in the cylinder. The valve number and CGA, or Compressed Gas Association number, must match. And again, go to their website and you can actually ensure that you have the right equipment for the job, and make sure it all lines up. And each time a compressed gas cylinder is used, the cylinder, the regulator, and connection should be visually inspected for disrepair or damage, right? So ensure that we're doing those visual inspections before we start to work, as well as maybe take a good look afterwards as well, just to make sure that nothing's changed. And it also says bond and ground all flammable compressed gas cylinder lines and equipment. We won't often see this, but it is something that is recommended as a best practice when it comes to that. So when using compressed gas cylinders, again, we want to keep the cylinder clear of all sparks, flames, and heat sources, ignition sources, things like that. Ensure the cylinder, the regulator, and associated equipment are properly maintained, right? Keep them clean. When working with toxic gases, the installation of permanent gas detectors or carrying personal detectors for leak detection, that's a requirement. So gas detectors and monitors, they need to be calibrated, as we had discussed before, and maintained as per the manufacturer's operating instructions, and keep records of this maintenance as well for any regulators that you're using or sensors. Use a flashback arrestor for flammable and oxidizing gases. It's going to stop the gas flow in the event of a reverse flow or flashback. We're going to talk about that as well momentarily and get into that a little bit deeper. And never open a damaged valve. If you have a damaged valve, contact your supervisor, notify the supplier. Do that immediately, because obviously if we have a damaged valve, we could have some potential issues there. Do not lubricate valves, fittings, or regulator threads. Consult the supplier for approved lubricants. Don't kind of use, things that might be common. I shouldn't say common practice, but conventional wisdom, I guess. Make sure that we're using the appropriate lubricants. Consult your complier for that. Again, as we said before, never use a gas cylinder as a source of compressed air. That's a terrible idea, and you shouldn't be using even compressed air to blow off coveralls and things like that, let alone a gas cylinder or cylinder gas. So, excuse me. Never heat the cylinder to raise the pressure of the gas, as this may defeat the safety mechanisms that are built in by the supplier. And we also had kind of mentioned, never use the copper fittings or tubing on acetylene tanks. It could result in an explosion. So under certain conditions, again, acetylene forms those explosive compounds with copper, silver, and mercury, and we kind of went over that earlier. So make sure that we're using the proper fittings when we're using acetylene compressed gas. So flashback, we just talked about flashback arrestors. A flashback is it can occur if there's a flammable mixture of fuel gas and oxygen in the hoses when the torch is lit. So a flashback is the reversing of the flame such that it's going to travel back or through the line back into the pressure regulator or cylinder. If it's not stopped, the flame will ignite the mixture and will travel backwards from the torch along the hoses through the regulator and into the cylinder. And that can trigger decomposition of the acetylene in the fuel hose and the regulator and in the cylinder itself. And like I said, we could potentially cause a fire or explosion if that happens. So you can see the two little the pictures there of the flashback arrestors, and they must be installed on the pressure regulator on both the acetylene cylinder and oxygen cylinder, with check valves for every 4.5 meters of hose used, so about 15 feet. In the event a fire propagates through the hose, that flashback arrestor is going to stop the fire from reaching the tank. Oftentimes we'll see them not installed at all, or we'll see them installed improperly. So again, they got to be installed on the pressure regulators of both the oxygen and acetylene cylinders. They also do expire, and the expiry date may not be indicated on the device itself. You may actually need to refer to your manufacturer's requirements when it comes to maintenance of your flashback arrestors, so definitely be aware of that. Some pressure relief devices that we will commonly see on compressed gas cylinders. You got three types here: the burst disc, fusible plug, pressure relief valve. So most cylinders are going to be fitted with a relief device. And in a situation where excess pressure is encountered, it's designed to discharge cylinder contents either completely or to discharge the excess pressure that's building. The discharge is normally accompanied by a high-pitched noise, so there won't be any sort of confusion about what's going on. That'll definitely be or could be your relief device. Most often used or most often seen is the burst disc, and then the fusible plug will often be seen on the acetylene tanks. And then you have your pressure relief valve and a little bit of a picture of what each looks like. So for these burst discs, in the event of overpressure, that valve is designed to burst and leave an open passage for gas contents to escape completely. So that's what those are used for. The fusible plug is designed to melt, and it'll release the contents completely inside of the gas cylinder. As I said, we'll often see these on acetylene cylinders. And then finally, the pressure relief valve. These valves are designed to relieve excess pressure and close again after releasing the excess pressure from the gas cylinder. So again, you might see a variation of these, and depending on what type of gas cylinder, they'll use kind of one or the other. So outdoor storage. So anytime any outdoor compressed gas cylinder storage location needs to be sufficiently far away from our building and opening based excuse me based on its ability, or I guess its expansion capacity. So we want to keep them away from the building as much as possible. Often we'll see them right off the side of buildings, which is fine. But again, if you have any concerns there, check with your local authorities, reach out to us, and we can kind of give you some feedback on that. So when we're storing gas cylinders outside, they need to be properly segregated. So we talked about that, including the empty cylinders. You had that TDG kind of example there before, how they should be stored, what they can be stored with, what they shouldn't be stored with. These storage areas, they should be supported on a raised concrete or some other non-combustible platform. They need to be locked in an enclosure used exclusively for compressed gas storage, right? We shouldn't be storing other equipment and things in there. We should just have that specifically for compressed gas. It should be surrounded by a locked fence, not less than 6 feet high. The gate must be able to open fully. The enclosure should be firmly anchored and built such that climbing is not feasible, and a solid roof structure is also required. So again, this is just going to try and prevent people from obviously breaking in, potentially stealing them. Also, potentially other issues if somebody does try and break in and gets a hold of these things, and we could have bigger issues on our hands. So again, it's meant for the safety as well as security of those tanks and loss prevention, I guess you could say. Compressed gas cylinders should be stored upright and secured with chains or straps. Typically, they will be kind of at the upper third, I guess, not at the lower part or the midpoint. If we see tipping, oftentimes they'll tip right over. So we want to kind of have it on that upper third of the compressed gas cylinder. They shouldn't be stored in, or I should say, compressed gas cylinders should be stored away from direct sunlight, heat, and ignition sources, as well as combustible materials. So we want to be aware of that. Again, 52 degrees Celsius, especially if these things are sitting right in the heat and the heat's on them all day. We can get up to that temperature pretty quick, not necessarily the temperature outside, but again, if it's left to sit there under the sun all day, we might have some issues there. So be cognizant of how you're storing these compressed gas cylinders. It's okay if they get a bit of sunlight, a little bit of cold, but we have to be understanding of what extreme temperatures could possibly do in terms of causing volatility to the cylinder itself. So just be aware of how you're storing it and the different seasons that we encounter here in Saskatchewan. And they shouldn't be stored near smoking areas, and I've seen this a few times. Again, we've got a potential ignition source there, so let's avoid that situation at all costs. Make sure that your smoking areas are well away from where you're storing your gas cylinders. Oops. Indoor storage, so cylinders being stored indoors, they should be properly segregated, including your empty cylinders. They should be accessible at all times, stored in a well-ventilated area, and located away from ignition sources. So make sure those things are all top of mind when we're storing indoors. They should be located at ground level, right? Storage shall not be permitted below grade, or I've even seen them actually stored on a mezzanine level, and that's just not appropriate. That's not right. We can obviously get an idea of what the potential issue could be there if one of those gas cylinders is to fall. So again, they should be stored at ground level. They need to be labeled or stored where the emergency contact names and numbers are prominently displayed. So again, make sure that we've got emergency information kind of in that area or in the area that they're being used so that it can be accessed quickly. Again, stored upright and be secured with restraining devices or inside protective devices. I don't mind the storage that we have here. Again, it's a little bit low, that chain. You can see it's at the midpoint. We're just more concerned if it tips, is it going to flip over that? So again, it could be certainly a little bit higher. You can see where that black line there is across the shoulder. It could be just below that shoulder, maybe about a foot or so. But again, it looks like it's stored fairly well and fairly taut. So that's another consideration to make. When we're storing gas cylinders, again, don't store them in stairwells, elevators, on mezzanines, near exit doors, or along exit routes. We don't want them to have kind of any sort of incidental contact where they could be tipped and we got bigger issues on our hands. They shouldn't be near the edges of platforms or where activities could cause damage to them. Again, make sure that we're not storing incompatible gas cylinders together. Give them the appropriate segregation and separation that's needed. They shouldn't be near corrosive materials like ice melting compound. Obviously, that can cause the gas cylinder to deteriorate possibly over time because of the corrosive materials. So let's be cognizant of that. And again, keep it away from ignition sources. When we're transporting gas cylinders, before moving the gas cylinder, we want to ensure that the outlet valve is fully closed. So and make sure that that valve protection cap is properly secured on the cylinder with the neck threads. Again, if we don't do that and this thing tips, falls over, and we shear off the top of that, we've just created a very large moving projectile comparable to a rocket because of the pressure inside that cylinder. So again, anytime we're moving the cylinder, we need to ensure that that safety cap is on there. Remove the regulator, right? Never move a cylinder with the regulator attached for the same reason that we just talked about. Make sure that your pathway is clear prior to transport, and be aware of any changes in your flooring grade, or if you're, there's gravel or whatever the case is. We have to be aware of those things that could cause us potential issues or tipping. And where possible, use an elevator. That's always a good way to transport gas cylinders if we have access to it. So always use a cart or a hand truck. Again, just we know these things can be awkward to carry. They can be heavy, so use a cart or hand truck. Alleviate some of the stress on the worker, on your back, on your shoulders, things like that. Again, let's make sure that they're secured with a chain or a strap across them. And once they're at the place of storage or use, secure that cylinder again, right? Some safe work practices. Do not drop a gas cylinder or allow it to strike other cylinders violently. I think that goes without saying, but for obvious reasons, we shouldn't allow that to happen. Do not drag, slide, or roll them on their side. That's another situation where we can cause contamination, deterioration, or damage to the gas cylinder. Do not lift gas cylinders by their valve cap. Right? Don't do that. Don't physically carry a gas cylinder. Again, we could cause injury. They're not light by any means. So let's make sure that we're using those carts or trucks to move them around. Do not remove the valve cap before the cylinder is secured in place, and do not move the cylinder with the regulator attached, as we discussed before. So to kind of cap things off here, our last section is on specifically Part 25 of the Health and Safety Regulations, which deals with fire and explosion hazards. And This slide is actually going to reference the information in that regulation 25-2, and it kind of gives us that roadmap to being able to comply with the regulations. It's meant ultimately to ensure the safe, when we have a fire safety plan, and I guess say that 25-2 of the regulations deals specifically with having a fire safety plan for your business. And it's meant to ensure safe and orderly evacuation of your business. Again, orderly, I think, is the key. We don't want people just running all over the place. We want to ensure that we have an orderly evacuation. It also deals with methods to prevent and control a fire. And owners must take all reasonable steps to prevent a fire outbreak at their business. So they are required to develop a fire safety plan for their business, even regardless of if we have gas cylinders on site or not. You might have other chemicals, flammables, and things like that. You need to have a fire safety plan at your business. So these next few points kind of summarize what's in Regulation 25-2, and I'll just go over them briefly. You can always refer to the regulations, and I will try and attach this as well in the links here to this video. A fire safety plan must include emergency procedures to be used in the event of a fire. We have to ensure that the quantities, locations, and storage methods of all flammable substances that are present at the place of employment. So again, when we're looking at propane, we're looking at acetylene, things like that. We need to ensure that it is known where the quantities and locations and storage methods of all of these items are. And that is for the fire department as well. If they respond to the fire, they need to know where you keep these flammables and what kind of quantities they're looking at. And that's for the safety not only of the folks at your workplace, but for anybody who might respond to the emergency. We need to ensure that, or our fire safety plan will ensure that we have a designation of persons that carry out the plan and their duties. These people need to be trained as well. We need to train those designated workers or persons, and we also need to train our workers to the fire safety. And this is going to include holding fire drills at least each 12-month period. You need to have a fire drill, right? And if you don't do well at the fire drill, guess what? You should probably hold another one within that same 12-month period. We want to make sure that we have that safe and orderly evacuation. And the only way to do it is to practice, right? So practice makes perfect. Ensure that you do it perfectly. And once we've done that, we can kind of move back to that 12-month period. But again, if we don't execute well, we should always hold an additional fire drill to make sure that we do it properly so that we're ready for those emergency situations. We also, the fire plan must include methods of control. And again, that might deal with not only having fire extinguishers, appropriate emergency equipment on site, but also, again, how are we transporting things? How are we storing things? How are we using them? All that stuff needs to be considered. And this fire safety plan, it needs to be posted in a conspicuous place for reference by workers. So again, we can put this on our safety bulletin board, we can put it in our shops, we can put it in a variety of different places, but it needs to be conspicuous and easily referenced by your workers. So when we're talking about welding, we are talking about hot work, and hot work means work that produces arcs, sparks, flames, heat, or other sources of ignition. And again, we talked about having those atmospheric sensors in place for the various different gas cylinders that would require it. So we need to have that information, those sensors in place. We also need to understand that fires often result they're often the result of the quick 5-minute job, right? I'm only going to be a minute, And when people have that kind of frame of thinking, the problem with it is that they don't take the time to take a look at the layout and the potential hazards of that area that they're working in, right? They just, only going to be a minute, quick 5 minutes. And they kind of, I guess they blind themselves or they just don't take into consideration potential issues with doing the type of work that they're doing. Anytime that we have sparks, flames, heat, ignition sources, we need to take a step back. We need to look at our work layout. We need to look at our equipment, make sure that it's properly inspected and we've done a proper hazard and risk assessment to avoid these incidents and these fires and things that happen because of these quick 5-minute jobs, so to speak. So employers, they need to ensure appropriate work procedures and training is in place and information is provided. And how do you do that? Well, how about you create a hot work management program? So if you're engaging in any of these sorts of practices, again, that produce hot work or arc, sparks, flames, heat, things like that, we should have a hot work management program in place. And this is what it would potentially look like. So, excuse me. Uh, the hot work program is used, or it's a plan, sorry, to control or eliminate hot work hazards and risks. And the plan should include the different policies, the different procedures, training, and communications that we're going to use to execute this program. And this all goes back to our general duties, right? What is the employer required to do? Well, they're required to have policies, practices, procedures in place and make sure that the information is communicated and their workers are trained on it. So this will really reinforce that part of the legislation. So when we look at policies, things we need to consider. Where is hot work permitted? Where are we allowed to do it in the shop or even maybe outside, right? Where is it permitted at our business? When is it permitted and who authorizes, performs, and monitors those hot work activities? Is it the supervisors, the shop foreman, some other managers, if the owner? We have to make sure that our policy clearly states who's responsible for what and when and the where of performing hot work. Procedures, and again, keep in mind, these are just some items on here. You might make more considerations and add to this list. But what must be addressed when we look at our procedures, looking at what must be assessed, before permitting or performing hot work in an area or on a process or piece of equipment or in a certain area. What do we do to prepare an area for hot work, right? So again, that comes down to the assessment piece. Are we stepping back? Are we preparing things for that type of work, or are we just grabbing the welder and going to work on something, right? Again, take that step back, make sure, and these procedures, this program is going to ensure that you're kind of going through a methodical method on how to ensure that we don't miss anything. What to do if hot work cannot be avoided in a particularly hazardous area? We're going to have to implement more controls, make more considerations. We might have to do a job hazard assessment and write a safe work procedure for this. So that's another consideration. What hot work tools are we going to need? How do we obtain a hot work permit when they're required, and who can administer them? Typically, we'll see it again come from the supervisor or shop foreman. And once they've given the permit, that should be an indicator to the shop foreman to go out and let me go and see how this work's being set up, and I need to go and supervise this area to make sure things are going hunky-dory. Training. Employees, supervisors, maintenance individuals, trained fire safety plan designates, and contractors. Everybody has a different role. Everybody needs to be trained to their role. So again, when we talk about training, and this isn't just for the fire safety plan aspect, but are they trained to use the compressed gas cylinders? Are they trained to use the equipment? All of these things need to be considered for the various individuals that are going to be kind of a part of this. So again, when we look at the training, we're going to break it down. The employees, supervisors, contractors, what sort of training is needed on site when we're performing hot work in that area. And finally, communications. And we talked about this at the start, and it just reinforces it. Making sure that we've developed procedures, that they're accessible and posted, making sure that we've got policies in place and guidelines and rules that people understand what the standard is at our business, and then posting signs in areas that are prohibited from having hot work performed in them. We might have areas in our business where we say, hey, this is a no-fly zone for that type of work because of the hazards involved. And we need to make sure that this information is communicated up front. So all these pieces taken together help you develop a hot work management program. And again, I'll try and attach some information here and some links so that you folks can access this. This is the best way to reinforce a lot of that information that you see in the regulations. So this brings us to the conclusion of our webinar today on safe use and handling of compressed gas cylinders and some tie back again to some welding safety components. It's a fairly large topic when we're looking at welding specifically, which is why we kind of just gave you some general information. Obviously, if you have any further questions, things like that, please feel free to reach out to us. Our number is 306-721-0688, and our administrative team will put you in touch with the appropriate advisor. You can also email our admin staff at info@motorsafety.ca, and they will direct you accordingly. Also, please go onto our website. We've got a lot of different work practices, procedures, courses, training, education, all kinds of stuff can be found on our website. So please go to www.motorsafety.ca to access that information. Have a good look around. And again, knowledge is power. So make sure that you educate yourselves, and we'll keep on doing these webinars. And I hope that you got a lot of information out of today's webinar. And again, please feel free to reach out if you have any questions. So that's it for today, folks. Thanks so much for joining us. Really appreciate your time. Hope you have a wonderful day, and we'll see you on the next webinar. Take care for now.